Hello, my name is Natalie Calvert and this is Lab 1 Charge Tapes. First, I want to introduce this lab and the purpose. The purpose of this lab was to take pieces of charged tapes and observe their interactions. Once this was done, we had to do a separate experiment that allowed us to calculate the excess or deficient number of electrons on the charged piece of tape. This process was done in the experiment and let us see what was true about the statement and what other calculations could be done. Some fundamentals in this lab are discussed by making estimates and assumptions, the idea of charge, and the amount of excess charge on everyday objects. Here are the materials we used to create this experiment. These are the equation constants that are going to help us do our calculations. First, we have Newton's second law, the electric field equation, and the electric force equation, which is Coulomb's law. Our constants are off to the side, some we measured and some we were given. So first, for our model, we want to make sure to model the pieces of tape as point charges when doing these calculations to observe the interactions on a much larger scale. This helps our calculations and for us to see it as just these 2 points in space with nothing else. The assumptions we have were that we assumed that each U-tape created had the same net charge, and we also treated each tape as if all its charges were located at a single point in the middle of the piece of tape. Both of these assumptions were to help us do our calculations much easier and to assume they were 2 point charges instead of charges spread out over this entire length and size of the tape. For procedure 1, we took 2 pieces of tape that were about 8 inches long and created a U-handle on each of them. We laid one flat down on the table and one on top of the other, and then we ripped one off of the other and we held it against other objects to see what kind of charge it had or interactions. So when I held this charged piece of U-tape close to objects, I saw that it was attracted to neutral objects. And when I created another piece of U-tape, it was repelled by this piece of U-tape. And to find out the charge that this piece of U-tape had, I created a negatively charged plastic pin by rubbing it against my head and saw that it was attracted to this piece of pin, showing that it had a positive charge. For this procedure, we had one charged U-tape that was between 2 thick books, and then we took another charged piece of U-tape and slowly put it under it and saw when it started lifting. And when it started lifting, that is the distance between them that we recorded. With this, we are going to be able to calculate the electric force between the 2 pieces of tape. So for procedure 2, we need to keep in mind that tape B is the system and tape A and everything else are the surroundings. I created a free body diagram to show the equal and opposite force between the electric force and the gravitational force. And by doing this procedure, we are going to be able to calculate the electric force between the 2 charges. So for procedure 2 calculations, we first calculated the gravitational force, and then we used that and made it equal to the electric force equation to be able to figure out the Q value. And once we had the Q value, we could calculate the electric field between the 2, and then that answer was 211,500 newtons per coulombs, and then we used that and multiplied it times the Q that we found to the left, and we got our final answer as 1.99 times 10 to the negative 3 newtons, which was equal to the gravitational force. So here's the code that I used. I have the constants first, the objects, and the calculations. I used the electric field calculations and multiplied that times the charge for tape B in order to create an arrow to show the magnitude of the electric force, and I did the same thing with the gravity. For tape A, I only did the electric field function, and then I multiplied that times the charge in order to get the force and used that to show an arrow for the magnitude as well. So here we have the final picture of my magnitudes being equal and opposite, as well as my calculations being very similar to the ones on paper. And we still had the same assumptions, assuming that the point charge with all that charge at the center point. We also had to assume that the U-tape had the same amount of charge evenly over the whole thing. So for my discussion questions, we said, what if electrons had positive charge and protons had negative charge? What would this change about the observations I made? So this wouldn't change anything because it would still be the same for all the observations, but everything would have the opposite charge of what it did. Why is it important to handle the charged tapes as little as possible, and what happens when the charged tapes encounter your hands or other objects? So you want to handle these with care because they could lose their charge if you touch it or rub it against another object, and this could affect the experiment. As we said before, that if you touch a charged object to something or you rub it against something else, they can lose charge or change charge very easily. For comparison, I think that my model on paper and my model on the code were very similar, and so were the numbers. Some sources of error I have were measuring the distance incorrectly, possibly touching the tape after it's been charged, resulting in some loss of charge, and the charges on pieces of tape may be unequal, unlike our calculated Q value. For my conclusion, I can say that an experiment like this is useful in the sense that we can use everyday objects to compute calculations that produce good solutions. Objects can exchange charges very easily just by touching or rubbing a neutral object. Electrical forces and fields play a big role in our world and are everywhere even though you cannot see them. And figuring out how to solve a problem written into code really helps you understand the problem on a deeper level. Thank you!